Thanks very much, Gus, and thanks everyone for getting up so early in the morning. Normally when I give a presentation, I'm a dean, I have to wear a tie like all week. So I like to dress down a little on the weekends, but today's a special because I got to go to a basketball game right after we're done here. And you don't dress up for those, you got to dress appropriately. As we're going to hopefully have a little more luck in our shooting and beat the Ducks. I'm a Pac-12 recovering addict, so this is important for me, and I'll be rooting for Michigan, of course. All right. Today, some people probably have heard me talk. I haven't given a whole lot of talks in Michigan yet, but I've really tried to move from being a person who really brings the global picture down to the region of the West, where climate change is really in your face now. You'll get a sense of that in this presentation. I work a lot on sea level rise too, and along our coast there are literally cities and towns now being flooded and people moving because of sea level rise. But my goal in moving to Michigan is to also focus on what's going on in Michigan. So this presentation will have that Michigan-centric component to it. We'll talk a little about the globe. We'll talk a lot about water. Which I think is, to me, something I've done a lot of research on over the years. It's the sharp edge of climate change for probably more people on the planet than anything else. You could argue maybe, and this is the lack of water I'm talking about, but also if you think about flooding and sea level rise, water becomes something that is a real problem already and growing. We'll talk about how this change that we've seen so far is more of an opportunity for Michigan, but if we don't watch out, that opportunity will instead switch over to a real problem or challenge for Michigan. So we have to somehow find that sweet spot, and it all comes down to acting on climate change as fast as we humanly can. And I want to end with my talk about how I think, the reasons I think there's real hope that we can do that, despite what's going on in Madrid right now, which I'll touch on briefly. Of course, when we talk about climate change, this is what it's sort of the iconic picture is the globe and how much it's warmed since we had thermometers. In this plot map from NASA, you can just see all the colors are places where we had thermometers going back to 1880, I think. And you can see the amount of warming that's occurred since that time. And so there are gray areas on the map, like Antarctica and the poles, and a few other spots, and those are places where we didn't have thermometers going back that far. But trust me, the poles are warming up dramatically, and you'll hear that from Dr. Pollack when he talks. But you can see in this map that we've warmed a lot, and it seems to be we've warmed a lot more on land than on the oceans, and that's exactly what we would have predicted. The whole planet is warmed about 1 degree C or 1.8 degrees F. It's warmed 0.2 degrees in just the last 5 years, so the warming is accelerating. And in the oceans, the warming is being taken up by the depths of the oceans. So over 90% of the heat that's been trapped by the greenhouse gases that we put in the atmosphere has gone into the ocean. And if it wasn't for that, we'd be a hell of a lot hotter now over land. But nonetheless, because of the higher when you're on land, the heat doesn't mix down into the ocean, you're getting more warming. And you're getting more warming at high latitudes, we'll touch on in a second, because of the fact that we're melting more white material, ice and snow. And if you do that, more radiation can be absorbed by the land surface and re-radiated to the atmosphere. That's where you get the warming. So that's what we call a positive feedback. And I'll talk a little more about that in just a sec. Okay, I want to just, in my talks, always sort of bring things right to the present day, literally. What's going on right now in the last 2 weeks has been a conference of parties, or a COP, that occurs every year since the Rio Convention back in '92, I guess, or somewhere back then. I'm not doing the math right, but somewhere after the '92 event, they started doing these regular meetings of all the countries in the world, about 195 to 200, trying to work out how to best approach climate change and deal with climate change. Well, there's one going on now Paris is the most famous one, where the Paris Agreement was signed. And they were hoping to get greater commitments out of all the countries this year than were achieved at Paris. And it's been a failure so far. But they just announced that they're going to keep trying. So they've actually extended the COP, and they're working today while we're talking, I suppose. They're working hard trying to come up with something. I wouldn't have great expectations. There are good cops and bad cops, as we all know. And right on the heels of one of the most notoriously unsuccessful COPs, the Copenhagen one, bam, we had Paris, one of them, certainly the most successful. So we hope we will come back with a roar to help solve this problem at a subsequent COP. But we're not anywhere close to having the commitments necessary to get to a world that warms less than 2 degrees C right now. Bad news. Why is it that climate scientists are so hell-bent on convincing policymakers and the public that we need to stay below 1.5 to 2 degrees C? Why is that the magic number? You know, a lot of people think it's just sort of pulled out of a hat, but it's not. The reason is because there are a number of tipping points or thresholds in the climate system that if we go over those thresholds, it'll be impossible to avoid additional warming, no matter what we do. And so we don't know exactly where those tipping points are, but we think they lurk in the range of 1.5 to 2 degrees C global warming. Let me show you what I mean. Okay, this is a paper that was not coincidentally published just during the COP, so it just came out a week and a half ago or so. And it was a bunch of scientists who study these tipping points. And they had one figure in there that showed some of the tipping points that they're worried about. And they wanted to highlight that these tipping points are not just each a threat to the amount of warming this planet is going to go through, but they can actually influence each other, and they can cascade. So it's possible that if we go across the threshold for one, then we're kind of on an irreversible path to 3.5 degrees C global warming. And we don't want to go across those thresholds. And yet we're worried that we already are touching or involving those thresholds. The one I'm going to start with that's most famous and that Dr. Pollack will talk about, I know he was just up in the Arctic Ocean in a ship, is B, up there at the very top. And I'll give you a hint, but B represents all this white area up here. What is that tipping point? Does anyone know? You know. Excellent. Exactly. Positive feedbacks. Ice. Whoa, let's give that guy a round of applause. That was excellent. Tipping points are positive feedbacks. A positive feedback I like to think of as an amplifying feedback. Once you start it, it continues to self-feed on itself to increase the amount of change. And he was right, sea ice. The Arctic is just melting much faster. This is the ice that floats on the ocean, not the ice on the land, but that's melting too, and we'll talk about that in a minute. In fact, that's letter C up there, I think. Oh no, which one? G. G for Greenland. Okay, but the sea ice has been melting much faster than we scientists predicted it would. And I worked a long time in the Arctic, and it's just literally flabbergasting what's going up there. And it's these positive feedbacks. So as you melt back the sea ice, you expose the ocean. And so you're taking a white surface of the planet and you're turning it into a dark blue surface of the planet. Which do you think absorbs more incoming radiation from the sun? Obviously the oceans. And those oceans absorb all that heat and they keep radiating it back into the atmosphere. So that acts and that warms things up. You melt more sea ice. That reflects less radiation. You warm things up even more. So we've kicked this feedback well into action. It is influencing the warming Arctic, the unprecedented warming there more than anywhere on the planet, has also started another set of feedbacks in the Arctic. Anyone have an idea what? There are two. This one, H, permafrost, right? It's right on there, so you can kind of cheat. And this one over here, boreal forest. What do I mean by, so the permafrost, just to nail that one first, what's happening is all around the circumpolar region, the soil's up there, it's too cold for organic material to decay. Instead, it just freezes and piles up over eons. All this carbon is just very thick soil. That's what permafrost is. And the permafrost can extend down into the rock, too, underneath that. But as the permafrost melts, warms up, it starts emitting that carbon in the form of CO2 or carbon dioxide and methane back to the atmosphere. So it's it is kind of like fossil. Of course, it's not that old like oil and gas. And it's pumping in the air. So we've actually gone across the tipping point now in many parts of the Arctic and so the net sink of carbon that used to exist there naturally is turned into a source of carbon to the atmosphere. And of course that means if it warms, it emits more carbon and to the atmosphere, methane and CO2. That means more warming. That means more melting. That means more greenhouse gases. See what I mean? It amplifies. What about D, which I hope says boreal forest? What's going on with the boreal forest that we're worried about? Hint, what's going on in Australia right now? Fires. The boreal forest goes these are think of it as, I don't know, millions of square kilometers of Christmas trees, big ones. And they're conifer forests, and they go all around all the land surface around the pole. And they burn very rarely. And the soils are permafrost and not well drained, so the soils stay wet. Now that soil is melting and it's draining, drying out, and and it's of course getting warmer, longer warm season, we're starting to get boreal forest fires. And once that really takes off, that's the next big tipping point that we're really worried about. And why does that burning constitute a tipping point? Because what's happening is it's taking carbon in the form of wood and turning it into carbon in the form of CO2 in the atmosphere. So you end up with additional warming because of that too. Okay? And then they draw lines on this, and there are all these other tipping points. These guys went a little too far, I think a bunch of my colleagues thought, in trying to connect to everything. But nonetheless, whether they're working together or they're working alone, these feedbacks collectively could cause the planet to warm quite a bit, and we just sit and watch. We don't want that to happen. That's why we want to keep the warming below 1.5 to 2 degrees C. There's that sea ice, but he was so fast I didn't even have to go to that. All right. Now I'm going to switch over to water supply, because I think this is something people don't talk about much when they're talking about climate change. They like to focus on, climate extremes that are affecting people more generally, and I'm going to do that too. But after living in the Southwest for nearly 20 years, and before that Colorado, it became really clear, viscerally clear, that the big limiting resource out there is water. Water for a lot of people and a lot of activities. For example, if you go to the market right now and get some lettuce, that lettuce is coming from the Southwest, and it's Colorado River water, either from Arizona or California. This is the Colorado River up in Utah. Did a boat trip a while back with the family. But what I want to do is not give you a picture gallery of the Colorado River, but try and connect you why this is so important globally. This map comes out of an IPCC, or Intergovernmental Panel on Climate Change report. And a lot of people like to say, well, they focus on, when they're talking about water, it's like, where's it going to rain more or where's it going to rain less? And we'll talk about that too. But one of the big discoveries, I think, that a number of scientists, myself included, feels really important, and I've worked a lot on this one in particular, is when you really talk about hydrologic balance as it relates to water supply or ecosystem health or pretty much everything, it's a combination of temperature and precipitation that you have to worry about. And everyone in this room who gardens knows what I'm talking about, or has a lawn. You know, in the middle of the summer, if you get an unusually hot day, you have to water more. If you don't water more, your plants or grass will wilt, turn brown, maybe die. That's the effect of temperature on your plants. Okay? If the atmosphere is warmer, it requires more moisture. It can hold more moisture. And it gets that moisture out of wherever it can get it. It evaporates that out of the Great Lakes here. It also gets most of it out of the vegetation. Vegetation all has little holes, little pores in it. We're exchanging CO2 and oxygen. And when those pores are open, in other words, when the plants are breathing, it's also allowing water to escape. And if the atmosphere is warmer, it will allow more water out, and the atmosphere can hold it and take it away. So these show where on the planet we expect this net effect of warming and drying, less precipitation, to affect soil moisture in a negative way. And my own gut sense, and this would be a good paper to write, no one's written it yet, but I think everyone's circling around writing it, is that this is the best way to portray where there are going to be water shortages as well. And I'll try and convince you of that before the end of the talk. What we're looking at, though, is something here everyone should understand, is that one of the things that climate scientists can't do is predict the future. We project into the future what we think the average conditions will be in the future. Just like we can say, what are the average conditions in Michigan in summer versus winter? And we can do that very well, just as we can project what the average conditions will be in the future. But we don't know, the biggest unknown is what will humans do? Will we put in a lot of greenhouse gases? In other words, will the oil companies of the world get what they want, pump all that oil, continue to make money for hundreds of years, get rich? If that's the case, then the planet will get much, much warmer. Or will the folks who are circling around trying to get the Paris Agreement strengthened, will they win out? Will we stop climate change? Well, we don't know that as climate scientists. We instead, though, will use scenarios. We'll run our climate models with high emissions, business as usual, oil companies win. We'll run our climate models with low emissions. Everyone else wins, okay? And that's what's depicted here. And that's what these numbers are. RCP, representative concentration pathways. This is just a pathway of concentrations of greenhouse gases in the atmosphere. The smaller the number, the smaller the greenhouse gas emissions. So you can see 2.6, 4.5, 6.0, and 8.5. Business as usual, high emissions here, oil companies win. Low emissions here, Paris wins, okay? And you can see, though, one interesting thing is that all the orange to red colors are where it's going to dry out. So even if Paris wins, parts of the world are going to dry out. Of course, if Paris doesn't win out, the oil companies win out, parts of the world are going to really dry out. And you can just see more clearly on this map where. They're the same regions on both of these maps. It's just a matter of magnitude. But I want you to check out, make sure the next slide is what I think it is. Check out this. I'm going to go right back, sorry. That's what I do. I try to think too hard. Southern Africa, everyone knows what's going on in Australia now. We predict it's going to dry out. Do people realize that Southern Africa is drying out dramatically? Do people realize the Southwest United States is already drying out dramatically? All right, Southwest. Okay, these areas are already showing clear signs that they're on track to what we're showing on this map. And if you go to the next slide, just to convince you, obviously everyone knows what's going on in Australia now, unprecedented drought. They just had an unprecedented drought like 10 years, 15 years ago. Well, they have another one that's worse. And in South Africa, it's really reaching the crisis stage now, where tens of millions of people are threatened with famine. And it's the same darn thing. It's getting too hot. And the rains in those areas are also failing more regularly. Right? So what has been predicted for 30 or 40 years is now taking place. Okay. Let's bring it back home. Home for me in a very literal sense, home for all of us because we're in the same nation. And when you start to have real problems in this nation, who pays for that? The taxpayers. Not always local, but everyone pays for that. Obviously the local folks pay more, and often with their lives. In the case of drought, What happens when California runs out of water? What happens when they start to have the wildfires? Insurance pays for it. Well, who pays the insurance rates? Okay. So it's important for us to realize that we're all in the same boat together. What happens when our coastlines get submerged? Okay. You could easily say, well, it's those dumb people down in Miami, they deserve it. No, that's not true. A lot of them are trying to fight climate change. But the U.S. will step in and spend huge amounts of money when a hurricane hits, a climate supercharged hurricane, or when they have to actually retreat and give up parts of the coastline to sea level rise. In the interim period, a lot of insurance companies will probably have trouble financially, and they will first try to get more money from the people who pay for insurance, which is everybody. Okay, back to this drought. This is something that I lived through. I moved to Arizona in 1999, which is the year the drought began. In that year, I got asked to go to Las Vegas and give a talk to water managers there. And I talked about, you guys, you know, the reservoirs are all full. You're feeling really cocky about your water supply. You got to worry about drought. And the drought immediately began. It's continued to the present day. These colors show where the drought is right now. And it's centered on Four Corners, which is the area between, you know, at the intersection of Utah, Colorado, New Mexico, and Arizona. That's where the drought is the worst. That's where the drought got started, down in Mexico, and moved right up there. And we had a huge die-off of pinion pine starting in 2002, because the drought was centered. It was a lot worse then, centered right on that same spot. Okay, but if you look at the next map, you can see a couple of the years between 1999 and today, just showing where the drought was. And yes, there are more red colors. So right now the drought isn't as intense as it has been. But 2002, you can see the drought in the Four Corners again, that big dark brown color. That's what killed off just an amazing amount of pinion pine. So the pinion pine juniper woodland became juniper woodland in large parts of Arizona and New Mexico. And then 2004, it persisted really bad. 2012, it was every year there was a drought just about. I think every year it was in the Southwest and in Arizona. And in 2012, it went out onto the high plains. It looked like a Dust Bowl drought. 2013, it looked like the 1950s, 60s drought, centered on New Mexico, Texas, and Oklahoma. So it's moved around, but it's been there. And it's been exacerbated by high temperatures. This drought is not like a drought of yore, which was typically a precipitation drought, less rainfall, less snowfall. This drought has that element to it for sure, but it's also got the problem of these really high temperatures relative to pre-industrial times. Okay, I've talked about this already. Pinion pine died off in New Mexico and Arizona. In California, when the drought was centered there a couple of years ago, unprecedented tree mortality there. These trees are dying outright because it's too hot and dry. Then they get attacked by insects and disease because they're weakened. One way or the other, they end up dying, and then they're more susceptible to wildfire as well. Wildfire in Colorado, I have a cabin there in southern Colorado. In 2018, I could see the smoke and have the ash falling on my deck from two separate fires. The West is literally burning up now. And that's a lot of carbon in the atmosphere, and of course it's a lot of threat to human beings as well, as we saw in the California fires, which actually burned through whole communities. And you just don't understand that sitting out here in Michigan, how bad it is out west. And part of the badness is the air pollution has gotten really bad. These fires are now the leading cause of the small particulate matter, PM 2.5, which is a very harmful air pollutant, which gets into your brain, it's been shown to get into placentas. It causes health problems, and people die because of it. Now I'm going to talk a little about the Colorado River. I'm going to talk about the Colorado River because it is the lifeblood, the #1 lifeblood of the Southwest. This is the basin of the Colorado River. It goes all the way up into Wyoming, comes down through Colorado, Utah. Those are the upper basin states, a little of the upper basin state in New Mexico. And then it also flows right along through on the edge of Arizona, California, and Nevada. 7 states share this water with Mexico because ultimately it flows down into Mexico, and true to life, it shows that the river just doesn't get to the Gulf of California anymore. It used to. Okay? Everybody's taken that water out all along the way, and by the time it gets down into Mexico, the last of the agricultural users use it up. It supplies the water, though, the drinking water, the only sustainable water, really, for many communities, all shown in red. Actually, it's not the only sustainable water. There's smaller rivers flowing for many of these cities, like Salt Lake, and even Phoenix has these other little rivers. But they all are part of the Colorado River Basin. So if this river was to dry up, or even to start declining severely, it affects about 40 million people, and that number of people keeps growing. This still is the fastest growing part of the country. And their economy is based on development, building more homes, basically, and all the services that people want when they move here. This provides critical water for LA and San Diego. It provides critical water for El Paso, Albuquerque, Santa Fe, Denver. Even though they're out of the basin, diversions have taken that water out there. So this river is really critical. And what's happening to this river? It was predicted it would happen. It is happening. It's drying up. This river has the 2 largest reservoirs in the whole country on it. Lake Powell at the border between Utah and Arizona, and Lake Mead, called Boulder Dam when it was first built back in the 30s, or Hoover Dam, and Boulder Dam. And so that name has oscillated between those 2 names, called the Boulder Dam now. And you can see, you saw in that last one hopefully, that collectively these 2 largest reservoirs are now less than half full. They've been that way for a while. I can't remember, if someone asked me a question, I could update this to the present day, but just showing how the reservoirs now, they keep declining year in, year out. If you have a really good snow year, they go up a little. If you have a bad snow year, they go down more. Last year was a good snow year, but they didn't go up very much. And scientists and water managers alike are really worried of a big crisis going on. Even Congress has gotten into the act and passed a drought contingency plan that was worked out among all of the basin states and their governments. Some governments, like Arizona, like to pretend that there's no climate change. They're solidly red states. Other states like Colorado, California, New Mexico, and Nevada all are like, climate change is a really big problem. They cannot agree to work on climate change together, but they can agree that we have to conserve more water. And that's what the drought contingency plan is all about, how to allocate cuts to all the water users in the basin. These are the big intakes that are normally under the water here, just in front of the dam, the Boulder Dam. So why is it drying up? You have the Colorado River, you have the Rio Grande, you have the Pecos, you have a lot of other smaller rivers in the Southwest. Why are they all drying up? Anyone want to guess? I kind of said it over and over again. He has all the answers. How about you? You've got one. Let's see if he can do it. I'm glad you gave me that answer. Too much water is being used. That's true. All the water in those rivers have been allocated and then some. Turns out the Colorado River, the first agreement was in the 1920s, how to allocate that water among the basin states. That was the wettest time in 1,000 years. So they over-allocated by 20% right off the top. What's the other reason? Climate change, warming, right? The same thing that's occurring around the whole planet is occurring in the basin right here. Okay, so even though the globe has warmed up a degree Celsius, the basin has warmed up 1.5, almost 2 degrees C. Parts of the basin have warmed up more than 2 degrees C. And that is literally taking more water out of the vegetation, out of the soil, off the snow, out of the rivers and reservoirs, and putting it in the atmosphere where it move somewhere else. Interesting enough, I think I moved to where a lot of that water's going. And we'll talk about that in a minute. Okay. So what are folks doing now? There's not enough water. It's over-allocated. It's too warm. The river flow's gone down by 20% in the last 100. Well, it's gone down by 20% just since 1999. And I would say at least half of that's because of warming, and the other half is precipitation declines. And what are people doing? If you ever go in the Southwest and you go to any agricultural area, and believe me, we have huge agriculture in the Southwest because the weather's perfect. If you have enough water, you can grow a lot. And we get all our winter vegetables except for asparagus from Arizona and California. And asparagus comes from other places. It has a higher carbon intensity because it's flying. But nonetheless, where do they get that water? They get it from the ground. Fortunately, especially in Arizona, they're gigantic aquifers, meaning groundwater is very plentiful. And when I first moved there, everyone talked about, well, you know, it doesn't really matter what happens to the rivers because we have a 35-year supply in the ground. You know, and moving from Colorado, I was thinking, well, that's great, 35 years, you know. Someone buys a mortgage, and maybe they'll have enough water to pay off their house. But, you know, we have the river, too. But now we don't. The river is getting lower and lower. And the first state that's going to lose their water from the river, in terms of big cities, is Phoenix and Tucson, is Arizona. They have junior water rights. And so the pumping is, I was also told when I moved there from friends in Phoenix that we've got a sustainable water supply. We're not pumping. Tucson, we're not going to pump anymore. We're just going to use the river water. Now they're starting to pump again because they don't have enough water. But this shows just where in the country they've studied it, aquifers that are being depleted. Yes, sir? That just means that there are two aquifers, one on top of the other. The Ogallala is, I think, the orange one. And then there's another aquifer that sits on top of it. And they're both being depleted, and they just want to show that there are two aquifers. That's what the hatching's about. Okay. Now, I am, and my wife is, and my kids are, we are climate refugees. For sure, this job here at the University of Michigan was an opportunity we couldn't turn down. It was great what Michigan wants to do in environmental sustainability. I was very eager to join and help work with colleagues to do it on and off campus. But we also were thinking our whole retirement is locked up in our house down there. And what if there's a water shortage and all of a sudden, like during the recession, the real estate values plummet by 50%? There goes our retirement. We decided it was wise to get out of there. That's one part of the world where I think increasingly people are going to stop moving to and start moving from. Especially as anyone, there must be, well, probably you guys are all hardy Michiganders. You're not snowbirds. But a lot of our neighbors, right, go down there in the winter. But that season where the temperatures down there are just so wonderful compared to here is getting shorter and shorter. And if you're there in the summer now, I mean, 115 is pretty bad, you know? Yeah, it's dry heat, you know. 105 there actually is about the same as 95 here. That's my calibration. But it's still pretty hot. Okay, here we have all the humidity. So what's another problem in this country that people are not paying as much attention to as they should, unless you're in Miami or Norfolk, Virginia Beach, New Orleans, Houston? These are places that are getting the full heads up that sea level rise is a problem. And they're not just getting it during the massive hurricanes anymore. They're getting it day to day in the form of what they call nuisance flooding. Water comes up through the manhole covers that are in the ground. It sort of bubbles up and floods the street, and they pump it back into the local canal, and it just keeps, it's like a cycle, right? Sea level rise is flooding out that city. New Orleans, if you look at these colors, with 1 meter of sea level rise, most of New Orleans will be flooded out and gone. That city will be the first U.S. city to be lost to climate change. But there are a lot of other smaller municipalities along this coast, and everyone likes to live along the coast, that are going to be flooded out. There's already in Louisiana a Native American tribe that lives in this neck of the woods that is being forced to move because their reservation where they've lived for generations is flooded and they can't live there anymore. The same thing is happening up in Chesapeake Bay, where there are islands that people lived that are no longer inhabitable. Up in Virginia Beach and Norfolk, where we, by the way, have our biggest naval base on the East Coast, they've raised many of the roads by a foot. There's a waste of money. The guys on the Keys, my wife was just down in the Keys. She's a climate scientist too. And they want to raise the roads by 3 feet, a little smarter. But you know, it's like hundreds of millions of dollars to do that. And the sources of money are just saying, no, we're not going to do that because it's just going to get flooded out. If we were to act on climate change and have a policy, then of course the money would be available. But why would it be available if you think your investment is just going to be submerged? So remember that map, the whole coastline. Of course, we have coastline on the west coast too. It's more, there's more elevation, more mountainous, but several meters of sea level rise will allow San Francisco Bay to reach Sacramento, for example. It's still real out there too. Here's an effort that colleagues did a couple of years ago, published in a science magazine, pretty prestigious journal that we publish in. And what they tried to do is convert climate impacts into, they tried to monetize it, calculate it in terms of economic impacts. And what they factored in was not running out of water in the Southwest or sea level rise. They left those off. I think they wanted to look more at the short term, things that they could actually turn into dollars and cents. You could see the list here of what they included. They did include the big storms, and I'm not talking about it specifically, but our hurricanes are certainly getting more intense, and they're certainly flooding more because the atmosphere holds more moisture. When you get any kind of storm, but especially a hurricane, a real storm, it's going to rain a lot harder. And that's why the main damage now from hurricanes is as much flooding as it is wind. They calculated that in. And you can see where in the country are these factors listed on this side going to lead to reductions in the gross domestic product. In other words, real financial damages. So if you live in those parts of the world, the economy is going to start doing less and less good, less and less well. If you add in sea level rise, you could imagine this whole entire coast is going to turn red. If you add in the water problem in the west, it's not just down here in Arizona, New Mexico, but it's all around this whole area. There's going to be a lot more dark red colors. Those are the places that are really going to suffer most. Interestingly enough, here we are in Michigan, and it's going to affect agriculture, and that's why we have some brown colors there. We're already moving to irrigated ag in this state, as you probably noticed. In other words, because of the hot temperatures, and the rain isn't frequent enough, we have to irrigate and use up our groundwater as well. Okay? This is an opportunity. And this is an opportunity I think University of Michigan wants to really try and seize with partners at other universities, businesses, communities, NGOs, anyone who wants to work with us on this. We're going to want to try and see if we can turn around our economy to ensure that it is climate change free and sustainable. And one way one thing that's really critical if we're going to do that is we have to attract more people and more talent and more businesses and more startups to the state, but we have to do it in a way that's more sustainable than we did in the past. And we think a lot of people are going to start thinking about Michigan if we can make it attractive in terms of education, recreation, healthcare, good paying jobs. What else do you think people really want? Infrastructure. There's something else. Clean water. Got to have clean water. We We have lots of water, but a lot of it isn't clean. Affordable, who said that? Yes, affordable. Who's been out to the Bay Area recently, or to Boston, or New York? Anyone have like kids or friends who are trying to buy a home out there? So many of our alumni have moved out to these areas, and they're doing great things in the, in terms of climate. But they're all telling me when I visit with them that they can't raise a family there. It's too expensive. So we have all this water, amazing amounts of water. We have to think about how we're going to use this water. And we're going to have to think about keeping it from getting all polluted. We don't want big polluting industry in the state anymore. Okay? And this sort of sets up this. I even threw a slide in here to highlight it, that people are, it's not just our alumni saying it's too expensive. It really is too expensive. So we have a low cost of living, and if we can just create those high-paying jobs and easy access to recreation and healthcare and quality education, a lot of folks are going to want to move here. That's why University of Michigan is in Detroit. Can we turn Detroit into a place that's really great for the Detroiters that live there now, but that is more economically sustainable and also environmentally sustainable? But, okay? If we don't do this right, we're going to be a whole lot of hurt as well. We're going to be a sacrifice zone just as much as New Orleans is going to be. And here's what I mean. We have a climate challenge. And I think a lot of folks know what this challenge is already viscerally, because all these things are already occurring. This is the same deal as we saw before, a little different in that we have only two climate emission scenarios shown on each of these maps. We have a low scenario. Again, this is more than Paris. So we could actually keep it cooler than this if we really get our acts together. And this is high. This is the same as I was showing before. It's sort of business as usual. Middle of the century, end of the century. But if we don't act, we're going to buy into this kind of thing. 8, 10 degrees warmer in Michigan in summer. So a really hot day where it's 95 and 98% humidity, be 105. That's like 120 down in Tucson. You just don't go outside anymore. Water. With the Great Lakes, everyone knows what's going on with water. But did you know why? All that water, look out here. Oh, shoot, sorry. Buttons are a little different. It's drying out here, but we're getting a lot more moisture up here. And this is the average moisture, change in the annual moisture per year. So that means there's just more rain in total year after year. And it's a pretty sizable percentage increase in Michigan, 10 to 15% increase in precipitation just over this last 100 years or so. Or no, over just relative to the 1901 to 60 average. So this has all happened really in the last 50 years, last 30 years. It says it right there. This map over on the left shows something completely different, which is really important to realize too. We're not just getting more precipitation in the form of rain and snow. It's falling a lot more intensely when it does rain or snow. You never believe that in Arbor when you get like snowflakes. You're in the snow globe day after day, or drizzle day. But on average, it's more than any part of the country aside from New England, our rainfall is intensifying. We're getting more flooding rains. So remember in the spring last year, this year, and before, getting the floods in Detroit and other parts of Michigan? That's because the rain is coming down a lot harder. And because there's more rain and it's coming down harder, our storm systems aren't designed to handle it, so we get flooding if you're in an urban area. And if you're a farmer, you get these waterlogged fields that just don't dry out until way later in the growing season. And that's why our agricultural sector is upset, rightfully so. They're being hit. But there's something else that this more intense, plentiful rainfall does. It's what's giving rise to these algal blooms. And Lake Erie is the poster child for algal blooms. It's also happening down along the Gulf Coast of Florida up over to Louisiana. There it's called red tide. But it's the same darn thing. There's more nutrients getting flushed off our farmlands into water bodies. And those nutrients are like fertilizer to the algae, some of which is toxic, the cyanobacteria. The algae also grows better when it's warmer. So it's really a perfect environment if you are a harmful algae. You have a bigger bloom. And that's why we're trying so hard to figure out ways to use less phosphorus on the farms, keep it on the farms, and keep it from going into rivers, lakes, and creating these. But we know that these are also expanding around the Great Lakes. It's not just Lake Erie anymore. We've had them in Lake Michigan. We've had them up in Lake Superior. Okay? So if we don't get a grip on climate change, what will it be like if every beach in the Great Lakes is got that green scum in it? And a lot of that green scum actually will cause you health problems if it gets into your body. Michigan will all of a sudden be a lot less attractive place to live. I've been coming to Michigan for ever since I got married 35 years ago or something, because my wife's family lives up on Lake Michigan. It's one of the most beautiful places in the world, and we could ruin that. Okay. Ironically, the same thing that's happening out west will happen here. You remember those maps I showed you of soil moisture? They showed red colors, orange colors up here. That's why we're going to more irrigated ag. Our soils are drying out, paradoxically, even as we get more flooding. Yeah, they're really wet in the spring when we have the flooding and the snow melt combined with rainfall, more rainfall than normal. But during the summer, it's getting so warm, you're getting soils drying out. And that means you have to have irrigated ag. That means forests are going to start, be weakened by the lack of soil moisture. That means that eventually we'll start having the kinds of fires they're having out west in our very own mixed conifer hardwood forests down here and the more conifer forests up north. You'll start to see more, I think this is probably a blueberry bush here, blueberry bushes. You're going to start seeing more of that. This is a fire in Michigan. I can't remember where, I think it's up in the UP. But we're going to start to see that. We're going to start to see forest dieback. And those of you who spend time in the forest know that a lot of our species are already having trouble with invasive species and disease. Think of beech. These trees are getting hit in multiple ways. And you end up with dead trees when that happens. And if they don't have moisture, they don't have their sap and other natural mechanisms to fight off insects and disease. And that's exactly what's going on out west. And of course, they waited until I decided to move back to Michigan. I did live here as a kid too. Early on, this is one of the last places to get Lyme disease in the east. And now we're getting Lyme disease. We're also getting mosquito-borne diseases, infectious diseases, that normally are just down in the southeast or even down in the Caribbean and Mexico, are now coming into the United States. Infectious diseases that are native to Africa can now thrive up here in Michigan. So you can see how this could get really out of control pretty darn quick if we're not careful. And of course, it's not just climate change that's caused by the burning of fossil fuels. Fossil fuel burning is the #1 cause of climate change. Coal, oil in your car, gasoline, and natural gas now. These are all horrible for climate, but they're also horrible for air quality. I didn't expect to move from the west to Michigan and have more ozone alerts than I had in Tucson. But I see that we have those. So just converting to coal to natural gas isn't going to do the trick. We've got to get off the fossil fuels because this air pollution now is causing up to 10,000 extra deaths per year in the United States. The wildfires are contributing as well, but of course the wildfires are dominantly caused by the climate change, which is again caused by the fossil fuel burning. So it all comes back to fossil fuels. There are a lot of other things we have to do, but fossil fuels are the biggest problem, the biggest threat to this planet and to every person in this room. It's that burning of oil, coal, and gas. Okay, what's the bottom line for us? I think you probably got the picture already. You know, someone a long time ago told me a good talk, always say the main points over and over again. Hopefully I haven't hit you too hard with these main points. But we could become a really thriving, middle-of-the-country economy if we can get into renewable energy really quickly. The talent that is moving to California, Boston, New York, DC, they're going there in part because those states are serious about climate change. That's another really critical ingredient. Imagine, though, if we all of a sudden are an electrified state and you can zip up to a Great Lake of your choice in your electric car, and the charging infrastructure is all there, so it makes no inconvenience whatsoever. The cost of your car, your trip up there, is half what it would be in your internal combustion vehicle. That's how much cheaper electric vehicles will be in just 5 years. Okay. This could be a great place for people to want to live. But if we don't embrace this future, it'll get worse here, a lot worse. Okay? So now, I thoroughly depressed a lot of people. If you're not depressed, you should be. Okay? So why do I have hope? I've been a climate scientist all my life. My wife has too. I think she gets more depressed than me about the situation. It's not really fair for me to say that, but I think she does. And I know a lot of my colleagues get very depressed because day in, day out, this is what we think about. And we see people in Washington just not listening. We see people in our own states just not listening. I was very happy to see new leadership in Michigan who listens. That's really phenomenal. I've never had that since I lived in Arizona, because there we never had that kind of leadership. You know, they always denied climate change. Although, interesting enough, even the most ardent political climate denier, I've learned, if you get them in a back room where they aren't in the public, they seem to understand the problem. It's just the problem is they can't acknowledge it in public because their political base, they'll elect someone else in the primary. The oil companies and the special interests have put so much money into the system that they're dead meat if they acknowledge climate change. Not democracy the way I imagined it when I was in school. Why do I have hope? I think what the youth of the world are doing is amazing. All right? It's these guys. You know, they're drawing attention to something that everyone else conveniently can ignore. And it's really, really important that they're doing this. I don't think activism can solve this problem alone, but I think it's a necessary ingredient. I think the students at the University of Michigan who are getting out there, causing trouble, you know, it's their lives, their future. But it's also all our kids and grandkids' future. You know? So the trick here is that we all need to work together. We need to work in companies. We need to work at companies. We need to work in communities. And with our leaders, we need to vote. We need to make climate change a #1 priority. Because it's gotten to the point where if we don't, the world is really going to suffer. Okay? But I really think people like Greta deserve the attention they're getting, deserve to be Woman of the Year. I'm also optimistic. I actually get choked up when I say things like that. I also think there's a lot of reason for hope just because of the economics of energy. I think we're going to see fossil fuel crushed. I had a really well-known investor tell me, use that term, and I love that term. I think fossil fuel is going to be crushed by the end of the next decade. We're already starting to see clear signs of this. They're fighting a death fight right now, but if they're able to prolong oil 5 years, 10 years, we're the ones who are going to suffer. Okay? So we have to shut down fossil fuels. But the thing that's going to shut it down is the cost of renewable energy now in many parts of the world is less than fossil fuel. The problem, of course, is that the fossil fuel industry keeps going back to Washington and getting more and more subsidies. They complain that solar and wind is popular and economical because of subsidies. Hogwash. The subsidies for fossil fuel are much larger. If we level the playing field and say no more subsidies, renewables have won. Okay? Wind and solar have won. And it's going to happen in the middle of by the middle of the next decade, 5 years from now or so. Battery storage will also be cheaper. We'll be at that level where we don't have to worry about intermittency. So this idea that we're going to need all these gas plants to deal with the gas power plants to deal with the intermittency is hogwash. You don't want to build gas-powered power plants anymore. You just shouldn't do it. You should take apart the coal ones, retire them, replace it with renewable energy, and you do that in a way that maintains that base load power until we've got it all done with renewable and batteries. I also have hope because every single nation in the planet except Syria and Nicaragua is still in the Paris Agreement. Yeah, we're going to pull out, but we're going to pull out right after the next election. So if the next election gets us a new president, we'll get right back in. Because the climate agreement was Paris Agreement. The Paris Agreement was designed just in case this kind of idiocy occurred. Okay? But for a while, we're going to be out with Nicaragua and Syria. Boy, how times change. But the point is the whole rest of the planet is moving in that direction. They're not moving in that direction as fast as we'd like. That's the quote-unquote failure in Madrid at the COP25 right now. But if every other country is trying to do it, they're buying renewable energy. There's a market for innovation in new energy efficiency and energy sources. In other words, the global economy is moving out in this direction while we hang desperately, along with Australia, onto fossil fuels. And all the future is in this and all the innovation, and that's going to drive down costs and drive up capability quickly into the future. I also have hope because a lot of states in the United States, sure, the United States is pulling out of Paris, sure, the White House is doing whatever they can to pander to fossil fuel, but a lot of states are saying, hell no, we're still in with Paris. And the states that are there, 24 of them, have a combined population of more than half of this country and a combined GDP of more than half of this country. So we're the biggest country, richest country in the world. A lot of people in a lot of jurisdictions in this state are still in. That's really important, including Michigan. And I think we're likely to hear from our governor. She's already said she's going to be in the U.S. Climate Alliance. We're going to start seeing some goals come out of Lansing pretty soon. And we just have to push them to make them better goals. Because these states are saying, oh, we'll go carbon neutral by 2050. Things like that. Well, that's not quick enough. Okay? This is news that just came out yesterday or Thursday. Okay? For 2019, the numbers are looking like the deployment of solar has jumped 23% in 1 year. This is the kind of growth we're getting. And it's happening around the planet. But even in the United States, we have 13 gigawatts of new installations by the end of this year. In China, just for reference, they'll have installed 44 in this year. So everyone's like, you still hear this in the halls of power. China's not doing their part. Bullshit. Not only are they doing their part, but they're going to capture this new economy. And the U.S. will be just like when we lost the car market to Japan in the 70s. We'll be sitting there twiddling our thumbs. What happened? We got to get into this market. And fortunately enough, states are taking this seriously, so I'm hopeful. It's not just states, but it's businesses, it's counties and cities, it's cultural institutions, faith groups, healthcare. This is a different organization we're still in. There are 24 in the Climate Alliance. There are only 10 in this states. A lot of universities, including the University of Michigan, are committed to carbon neutrality. And we will, in the end, commit to carbon neutrality in an aggressive enough fashion. I'm convinced of that. But you have to wait a little longer for us to figure out how. It's not easy. My old university, meanwhile, just announced this week that they're going to get all of their purchase to power from mission-free renewable energy. University of Arizona is not as big as University of Michigan, but it will be the biggest research university in the country on renewable electricity. And they're committed to that. And I mean, when I was there, and this is in a red state, okay? Deep red. So it's impressive. This is happening. Oops. And the other thing that gives me hope, and this comes out of Yale, they do the best, or at least the most comprehensive through time surveying of Americans and how they feel about climate issues. The estimated percent of adults in this country who think global warming is happening is 67%. 16% of Americans think it's not happening. And you can see spatially here where there is a lot more belief that climate change is happening, not surprisingly, in Southwest, where people are feeling it every day, day in and day out. There's more agreement that it's real. In Washtenaw County, yay, there's not a lot of thought that it isn't real. And that's probably why Washtenaw, Ann Arbor, University of Michigan is going carbon neutral, yay. And there are very few places in the United States that don't have a majority of Americans thinking it's happening. A majority of Americans in those same places generally all believe it's due to human activity too. The numbers aren't as high, it's only around 51%, but nonetheless, this country, the voters understand this. It's a special interest or keeping the voters from being heard. Just my sense, my guess. Okay. Another Yale study looks at a different way, and they found that only at this point, at the end of 2018, only 9% of Americans are just dismissive of climate change. Unfortunately, they are running the White House and the Senate. So what does this all mean for us again? You know, we all need to work to get it done. And so if there's anything you can't leave this room saying, oh, shoot, something has to be done. Everyone in this room has to think what they can do. And fortunately, we can all vote. We can get out the vote. That's the most important thing we can do. Obviously, Michigan is one of those swing states. So if you really are worried about this problem like I am, we have to do something about it in your own way. You can all figure that out. We have a lot of things we can do in our day-to-day lives as well. U of M and Ann Arbor are both working on paths to carbon neutrality. Neither one knows how they're going to do it. Get involved with Ann Arbor's efforts, with Washtenaw County's efforts. U of M is always taking, the commission, the President's Commission on Carbon Neutrality is always soliciting information too. We have members from the county, we have members from the utilities, we have members from Ann Arbor on that commission. So we're coordinating and we're going to get it done. And we're going to be the #1 research university in this arena by the time, hopefully this year's out. Not this year, next year. So with that, I'll just leave it up to questions. I probably went too long. I did, just about right.
Thank you, Peck, for a very hopeful ending. I'll let you, anyone who wants to leave, head out now, and we'll start questions in just a couple minutes.